Now, the next segment here is prime factorization. What do you understand by prime factorization? Here, it's made up of two words, prime and factorization, right? So, factorization is again a word which is made from the word factors, and you are familiar with the factors, right, of the number. And prime factorization means the factors which are prime numbers, okay? Factors which are prime numbers. In that method, if we proceed, we will get the prime factorization of any number. Let's take an example here of 36. So here if I say I can write 36 as 2 into 18, I can write 36 also as 3 into 12. I can also write 36 as 4 into 9. And I can also write 36 as 6 into 6. They are different factors of 36. Let us see here, are all the factors which we found, are they the prime numbers? So when we check, we find 2 and 18. 2 is a prime factor, but 18 is not a prime factor. 3 is a prime factor, 12 is not a prime factor. Here 4 and 9, both of them are not the prime numbers. 6 and 6, they are also not the prime numbers. So can we further factorize them? Yes. So for 2 and 18, I can again break 18 as 2 times 9. Similarly, 3 will remain as it is because 3 is a prime number. We will split the number which is not a prime number. So in this case, we will split 12. So 12 will be written as 3 into 4. Then 4 times 9. Can we split 4 and 9 both? Yes, we can do 4 as 2 into 2 and 9 we can do it in the next one also. Similarly, 6 into 6 we can write it as 2 into 3 into 6. Further, we can find the factors of this number, like 9 can be split as 3 times 3. 4 can be split as again 2 times 2. Again 9 can be split as 3 times 3 and 6 can be split as 2 times 3. Now, is the final product, in the final result, are we having all the factors which are the prime numbers? So you can see here that we are having here 2 2's, 2 3's. Similarly here also 2 3's and 2 2's. Again 2 2's and 3 3's are here. Here also we have a pair of 2 2's and 3's. That means overall if we see the factorization of the number 36, we will get that final 2 into 2 into 3 into 3. That means 2 times 2 times 3 times 3. So here we have all the factors which are prime numbers now. So in this way we can find the prime factorization of a number. There is one more method to find that out. Okay, we conclude from this particular part that all the factors are here. So the prime factorization of 36 with whichever method you do, whatever method you are doing, right? If you are splitting it as 2 into 12 or 3 into 12, final factors will be 2 into 2 into 3 into 3. That is this. That means the only prime factorization, because you have a single set of prime factors, right? It's not like if you do it like this, you'll reach some another answer, or if you do like this, you reach some another answer. No, it is not like that. It will come out to be same with whatever method you are doing over here. Okay. Now, let's see the next thing here. One more method. If I ask you to find the prime factors of three numbers, 16, 28 and 38. In that case, how you are going to find out? Shall we find them all separately? Yes, you can find the factors of a number using a trick, using this method. And when we do it like this, we call it a method of prime factorization. So how we are going to start with it? Let's see. First of all, if I am writing the number 28, then I know 28 is divisible by which smallest number. So when we see the prime factors, here we will represent all the prime numbers, right? Because we are doing a method of prime factorization and we have already done the divisibility rules. So we will check whether the number is divisible by the smallest number. We will start always from 2. Okay, so let's check. Does it come in the table of 2? Is it divisible by 2? Yes, because what does the divisibility of 2 states? It says that if the last digit is an even number, or if the number is even, then we say that it is divisible by 2. So if we divide 28 by 2, what will we get? we'll get the result as 14. Here we'll get the result as 14 because 28 divided by 2 you will get 14, right? In other way, in short, what you can do here is, see, if I divide this 2 by 2, I'll get a 1. If I divide this 8 by 2, I'll get the number 4. In this way, we don't do division in this manner, right? So directly here you can do this division part. Now again, we can say 14, it is divisible by 2 because again it's an even number, and you know 2 7 times is 14. So we can write here that 2 sevens are 14 and 7 ones are 7. So 7 is divisible by 7 only. It will not come in any number before 7, right? So we can directly do 7 into 1. Now here, what is the prime factorization of 28? When we'll write this, we'll get the number, the product of all these, just these. These are the prime factors of 28. So 2 times 2 times 7 will be the prime factorization of the number 28. Similarly, you can try for 16 and 38 also, right? After finding this, let us move on to the next segment, that is the highest common factor. It's a very interesting topic because if you are thorough with the topic of factors and common factors, then highest common factor is a very simple one, right? As the name depicts that it is the highest of the common factors. So for finding the HCF, first step that you have to do is you need to find out the factor of the number first of all. Okay, first thing is you need a factor, then we will find out the factors which are common. Okay, and then we will find out which is the highest of the common factors, and in this way we will get the highest common factor of the number. Okay, let me ask one thing here. Can we find HCF of one number? No. For one number we can find the factors. For finding something common, at least we need 2 numbers, because if there are no 2 numbers, for what we will find the common thing? Right? So whenever we find HCF, we must have minimum of 2 number. There can be more than that as well. Now let us see some example for this. So if I ask you to find the factors of 28, as we have done in the previous segment also, we get 2 into 2 into 7. Now let me find for one more number, and the number is 36. So 36 is divisible by 2. Now, how can we do the division? Let's see here. In this case, when we start with the division, see, if I divide 3 by 2, what I'll get here? I'll get the result as 1, right? 2 ones are 2, but we wanted 3, so we want one more. One more will go carry over to the number 6 and it becomes 16. Okay, now 2 8s are 16, so this becomes 18 in this case. Right? In the previous question, in this one, you can easily see 2 1s are 2 and 2 4s are 8. So you can easily write here. But in this case, if it is not coming in the table directly, then we can keep a carry over to the next digit and we proceed as we do a normal division. Okay. Now here you get the number 18, and if we proceed further, again 2 9s are 18. Now 9 is divisible by 3, not by 2. So we'll write here 3. And 3 times is 9. So 3 3s are 9, and 3 is divisible by 3 one time. So here we will get the number. So what are the prime factorization of this? 2 times 2 times 3 times 3. This is the prime factorization of number 36. Now let us take the third number. So let the third number be 20 here. Now 20 is divisible by 2, right? So 20 divided by 2 gives you 10. So we'll write here 10, and now 10 is divisible by 2 again. So 2 5 times 10. So we'll write 5 down, and again 5 is also divisible by 5. So 5 1s are 5. In this way we get the prime factorization of the number 20 also, right? After completing the method of common factors using the highest common factor technique, now let us move on to the next segment, which is the lowest common multiple. In short, we call it as LCM. Now what do you understand by LCM? So again, as we have done in highest common factors, it is the factors which are common and highest of all the common factors. So same we can go for LCM also. LCM are the multiples, then we'll go by the common multiples, and then we will find the smallest of all the common multiples. So let's find out what is LCM of the two numbers. So LCM of two numbers is the smallest or the least common multiple. Let's understand this concept with an example. So here find the LCM of 12 and 18. So for finding the LCM also, we have to find the prime factors of the number 12 and the number 18. So if you go by prime factorization, you'll find the factors of 12 as, see how we can find that? I can write here for 12, I can write 2 and 2 6s are 12. Again it will go by 2 and 2 3s are 6. Again it will go by 3 and 3 1s are 3. In the same manner for 18, I can find out by 2 9s are 18. Then 9 is divisible by 3, so 3 3s are 9 and 3 1 times is 3. So I got here that the prime factorization of 12 is 2 times 2 times 3 and the prime factorization of 18 is 2 times 3 times 3. So now if I write the prime factors of these two numbers in this manner, now after finding the multiples, that means it is a multiple of all these factors, right? So now let us find the common multiples. So here we find that 3 is common and also we find that 2 is also a common factor here. So is there any other factor which is common? No. But we find that 2 and 3 are the common factor. Now here you need to pay attention that if we have to find the highest common factor, your result should be 2 multiplied by 3. That is for finding HCF, for finding the common factor in the highest common factor. The result will be 2 3s are 6. But when we find the lowest common multiple or the least common multiple, LCM, in that case we take all the factors, but in a sense that we take common factor as one time only and we also take the factors which are not common. So which factors are not common here? We get 2 and 3 are not common, and here we find that a pair of number 2 is common and a pair 3 is common. So when we find the LCM of the numbers 12 and 18, see what we will do here? We will simply find out, like we'll include the number 2, 3, 2 and 3 also. That means in this case we have taken the factors which are common 2 and 3. So 2 and 3 are taken one factor which is common out of these, and other than them we have taken the factors which are not common also. That means this 2 individually and this 3 individually. So remember, while taking the LCM, we are not excluding the uncommon factors, we are taking them also into account. But while finding the highest common factor, we ignore the factors which are not common. We are only taking the common factors in HCF. In LCM, we go by all the factors, taking one out from the common factors and all other uncommon factors also as a product. So I hope the concept of LCM, HCF, factorization and they all are clear to you all. Hope this chapter is now clear to you. Thank you so much.